Okay, so in this video, there's only one topic that we want to talk about. We're going to talk about, and it looks like it's getting cut off here, but we're going to talk about building, right, or creating linear functions. And we're just going to do some examples from a description. And I think, we've already talked about this in class, but one of the most crucial things is that linear functions have a very predictable form, right? And that form looks like this. And this is something that you probably saw in middle school. So a function, a linear function, can always be written in this form here. We call it mx plus b form. Okay? So m is our rate of change. Okay? Our constant rate of change, or our slope. Sorry about that. It's our rate of change. Right? I'm going to use a symbol triangle for change. We've seen that before. Okay, so m is our rate of change, and b is our y-intercept. Okay? Our y-intercept. And remember, that also can be our output when the input is 0. Okay? So let's start by taking the examples from class, right? And we'll write functions for them. So if you remember the stacking cups example, we knew that each cup, let me write that a different way. We knew that the rate of change as we stack the cups on top of each other. Let me draw this quickly. Here was a cup. Right? And remember, it had the lid, and then we put another cup on top of it, right? And it was every cup that I added 10 millimeters. So it was 10 millimeters per cup, okay? And so that was our rate of change, right? It was 10 millimeters per cup. And this, the bottom part, the rim of the cup was 40 millimeters, right? So our function rule, right? This is our y-intercept. When we have no cups, we just have this one rim, we just have this one base. Our function looks like this. So it's mx, right? So 10 times the number of cups plus, 40. Okay, so this here, right, says 10 millimeters for each cup and a base of 40. Okay, so f of x is going to tell us, if we have x cups, f of x will tell us the height of the stack. Okay, so now we'll look at the oil change example. So we know that, let's see, what do we know? We know that I started off, right? So I started off with 25,000 miles. Right? And we wanted to write a function to predict how many I'd have after X days. Well, remember that we decided that my rate of change, right, driving to school and back, is 48 miles per day. So if I want X days, well, now this is a little easier, right? So the output is equal to 48 times the number of days plus the 25,000 that I already have. Okay, so if I wanted to figure out how much I'd have after 10 days, right, let me just grab a different color for this. Well, now all I have to do, I said if I want to know 10 days, I just plug in a 10 for x. So f of 10 is going to be 48 each day times 10 days plus 25,000. And then I calculate that, and I end up with 25,480 miles, right? So once I have a function, it's easy to find new values, or to find particular values that I'm interested in. Okay, so moving back, now we're going to do a couple of new examples together. As soon as I get back, there we are. So we'll look at a taxi cab problem. All right, so right, if I want to do this, I need to identify my rate of change and my y-intercept. Okay, so here we go. We've got Wilson's Taxi charging an initial charge, right? And then be careful on this. This is $4 for every half a mile. So the y-intercept's pretty easy to find here, right? As soon as I get into the car, whether I ride or not, they're going to charge me $4.50. Okay, that's my y-intercept. If I go 0 miles, that's my cost. Now the rate of change, right? I could do $4 for every half a mile, but I'm going to have x represent the number of miles. So my rate of change here has to be in dollars, right? Cost per mile. So if it's $4 for half a mile, right, I'll just double that and I'll get $8 per mile. Okay, so the rate of change is $8 per mile. So my function, right, once I have the rate of change and I have the y-intercept, is easy to write. If I have an x mile ride, it's just going to be, let's see, $8 a mile plus the $4.50 in initial charge. Okay? In this last example that we're going to do, we had a pool, and it looks like we weren't actually filling it. It looks like it was leaking, because after 10 minutes, it only had 4,500 gallons. So this one I'm going to need to find the rate of change, right? And this is nice. We're allowed to assume a constant rate of change. Okay? So this is going to be gallons per minute. So the rate of change, I went from 5,000 gallons to 4,500 gallons. Well, I know that's a loss of 500 gallons. So I'm going to write negative 500 gallons in 10 minutes. All right, so a little quick division, and I know that the rate of change is that I'm actually losing, so it's going to be negative 50 gallons per minute. And my y-intercept, that's usually the easy one here. That's my starting value, which in this case is 5,000 gallons. All right, so my function then, well, I should say what x is going to represent. I'm going to say that x is going to represent the number of minutes. So that's the number of minutes that have gone by. And I'm going to write this thing two different ways here. Okay. The first is the way that we've done in the past. 5,000 minus 10. Let's go back. 5,000 minus 10 each minute, right? But another way of writing that, I can make this, oh, I'm sorry, that should be 50. 5,000 minus 50. Let's see, can I rig that into a 50? Yes, I can. Okay, so I know that as long as I keep the 50 negative and the 5,000 positive, it's accurate. So I'm going to rewrite it like this. So it's minus 50 each minute plus the 5,000 that I started with. Okay? And these are both the same. This looks more like our mx plus b form, but this is probably a little more logical for you. So you should be able to use those to create the 4 or 5 functions that you have on your homework. And good luck with the assignment. Thanks for watching.